Welcome to an intro to trigonometry, part one. So why do we even need this? So in the trades, or especially as carpenters, we deal with triangles a lot, whether that's in stairs or in roofs or building overhangs. And often we will be given the lengths of certain pieces, and we might need to find out the degree of the angle that we need to cut something at, or we do have the angle and we need to find out how long the pieces need to be that we're cutting or preparing to later install, or perhaps doing site layout with a theodolite. So trigonometry comes in very handy. You might remember the SOHCAHTOA, if you've heard of it before. I love the addition of the triangles. As carpenters, usually we're very visual people, and the triangles just help us visualize it a little bit more, and it gives us something to hang on to should we ever forget what it is we're doing, and we can kind of backtrace our steps. Now, before we actually get into it in a big way, I would like to just get comfortable with the calculator first. So if you're in the trades, most likely you have a calculator that looks something like this. And at the top here, you'll see sine, cos, and tan functions. So those are the functions that we're using in trigonometry. So before we get into actual equations, I would love to just get used to a little bit. So we'll start with sine, and all we need to do is punch in the sine and then the degree number. And that gives us the version into something that we can math with. So sine 26, about 2.438. And usually we like to keep 3 or 4 decimal points. Sine 53, and at any point you are totally welcome to just pause the video and just go through them all, and then we can double check together and make sure that they worked out for you. So sine 53.79, and here we can round, so 799. 799. I like to talk out loud when I write down numbers, and when I'm reading them, it's an extra step or extra way for me to double check to make sure I punch things in right and that I'm actually copying down the correct numbers. Now, let's move on to cosine here. So we are punching in the cos button and 6.995. 0.995. How about cos 58? Punching that in. 0.52. It's really 0.53. We're going to round 0.53. And best as always, if you can just keep it in your calculator to then continue mathing with, that is the best way because you have all the decimal points. Okay, let's move on to tangent. So we're hitting the tan button and 25. A little bit for you. There you go. So 0.467. 0.467. And one more, tan 77. 4.331. Alrighty. So from here, I hope that that made a little bit of sense. And now we can actually move on to see what we're actually going to do. Okay, so the SOHCAHTOA is what you've usually heard. And the triangles are fantastic because they help us visualize things. So within the SO, we have the sine, so that'll be the angle of the triangle that we're working with. We have an opposite side and we have a hypotenuse. And the first step in trigonometry is always to find out what sides do we have, which ones are given to us, or which ones are we looking for, and which angle are we working with? Because you might be given two angles in a problem, and it just depends on which angle you're choosing to work with that then informs which sides are what. So we'll go through briefly, and I'll show you what I mean. Okay, so in this one, we want to work with the so. So a sine, we have an opposite and a hypotenuse. We have an angle given here. Whatever the degree is, doesn't matter. The important part is that we're going to work with this angle to solve a potential problem. So H for hypotenuse, that one is always easy. Hypotenuse is always the longest side, right? Just like in Pythagorean. So that's H taken care of. S, that'll be the angle right here. And we have an opposite. And the opposite is always directly across from the angle that we're working with. This side right here will be called adjacent, A. But that one is not part of so. So this is the first step, writing out what the sides are, what do we have, what's given to us. Let's move on over here to the ka. So in this version, we are using cos because we have available to us an angle, a hypotenuse, and an adjacent side. So either they're available or that's what we're trying to figure out. So this is where our angle is. Hypotenuse is easy, always the longest one, and the adjacent is always the side right next to the angle. Okay, so adjacent is right next to the angle, opposite is across from it. So and ka are easy to determine because we are using the hypotenuse. So that is a first step and really easy indicator. Do you have a hypotenuse given or are you looking for one? And then either if you have it or looking for one, you can use so or ka. And if it's not included in anything, then you're going to use the toa. So let's move on to that one. Let's check it out. So we have the angle still in this corner, but now we have an O and an A included. So O is the opposite, so that'll be this side again. And A is adjacent right next to our angle. Hypotenuse is, of course, up here, but we're not working with it, so I'm not even going to write it in there. The cool thing about these triangles is that it makes it really easy to figure out which function or which equation you have to use. Depending on what you're looking for, you literally just blot it out with your finger. So let's say we are looking for the opposite and we figured out that we need to use TOA, then it would be T times A. Imagine this line right here is like a divider, like in a fraction. So if we were looking for A, it would be O divided by T. That's why I really like it, because you can just blot out whatever it is you're looking for and then you can see what's left. Bottom across is always multiplied. Top to bottom is always divided. Okay, so let's check out the bottom here. Now that we are a little bit more comfortable, you can pause here as well, try it out on your own, and then see where you're at. See if we come out with the same thing. So we're back into so here. Now the angle has moved to up here. So let's see what we have available. We have S for our angle, H for our hypotenuse, and we need to find out the O. So before, when the angle was in the sharp corner, the opposite was across here, but now because we're working with the angle that is up here, the opposite is all the way on the other side. So you can see here how it moves around, but the hypotenuse always stays the same. Let's move on to the next one. We're back to ka. Again, the x or the angle that we're working with is up here. H for hypotenuse stays the same, but we need to find out the adjacent side. Adjacent to our angle is right here, and the adjacent and opposites are never the hypotenuse. So that's how you can easily figure out which one is which. The longest is always the hypotenuse, which must make this one the adjacent side. Now let's look at the last one, TOA over here. Angle is up here. We don't care about the hypotenuse, so we're going to leave it blank. So we have the opposite and adjacent to play with. Angle is here. Adjacent must be here right next to the angle, but not the hypotenuse. And the opposite is directly opposite from that angle. So there we go. That gives us an idea of how to set up for our mathing. And this is always the first step. Which sides are given to us, or which sides and angles are we trying to look for? That way we can then figure out whether we use SOHCAHTOA or TOA. Okie dokie. So now that we have SOHCAHTOA and TOA here, let's see what those equations would actually look like. I'll block off the two that we don't need quite yet. So what if we're looking for S? So meaning we are looking for the angle and we have the sides of the triangle given to us. So we block out the S, write that down, S equals. And what we have left is O divided by H. The beauty is, as soon as you have this written down, the next step will just be to pop in the numbers and then do the math. Okay, next one. What if we are looking for the opposite side? So O equals, and what do we have left? S times H. Then we have one left. What if we're looking for the hypotenuse? Then we have O divided by S. And that's how she goes. Now let's move on to the next one. Now we're in Ka. This was so, oopsie, Ka. So let's say we are looking for the angle. So C equals, and what we have left is A divided by H. Now, what if we are looking for the hypotenuse? Then we have hypotenuse equals adjacent over cos, so over our angle. And then our last one, what if we're looking for the adjacent side? Then we can multiply our cos angle, right? Cos and then angle times our hypotenuse. So C times H. You can see how this is quite repetitive for all of them, but it's really important that we can figure out which one we actually need to use. Now let's check out the last one. That's TOA. Okay. What if we're looking for the angle? So T equals O divided by A. What if we are looking for the adjacent side? We have A equals O over T. And then one last one. What if we are looking for the opposite? Then we have T times A left over. And those are all the functions. So today in this video, we're going to focus on the functions where we have an angle given to us and we're looking for a side. And then in the next video, I'll show you how to find out the angles if we have two sides given to us. This here is a reminder. So TOA. Sorry. So that we know what we're working with here. So we have our and TOA. Okay, so now we actually have some triangles that we can work with, and I'll blot out the ones that we don't quite need yet, so it doesn't get too confusing. So on this first triangle, we need to find out what we have. So we have an angle given to us right here. That's excellent. So we're going to work with that one. And we have a number given to us that is opposite of the angles. So we're going to mark that as opposite. And I see a question mark on our hypotenuse. So we can also mark our H here. Of course, when we're figuring things out, it is helpful to write in what we also don't maybe need, just as we're trying to figure it out. So this is the adjacent side, but it doesn't have anything to do with what we're doing. So I'm just going to cross it out so I don't confuse myself. There's always so much going on in math that it's easy to get overwhelmed. Okay, we are trying to find out the hypotenuse. So what do we have here? We have an H and an O. So looking at my options, which one has an H and which one has an O? Well, H, so it must be so or ka, but we have an opposite, so the O. So to me, that means we are gonna use so, and we are looking for the hypotenuse. So I can blot that out and figure out which one we need to use. So hypotenuse equals opposite over our sine angle. Is equals so. So hypotenuse over sine. There we go. Okie dokie. So from here, let's put this here so you can see it. Now we're just plugging in the numbers. We still don't know what H is because we want to find that out. O is 9.5 over S. So that it means sine of the angle that we are working with. So sine 45. And now all we're doing is punching that into the calculator. So 9.5 divided by sine, find that button again, 45. And that should give us the length of the hypotenuse, 13.435. There we go. First one solved. Hooray. Okay, let me move that over so we can get to the next one. Here we go. Okay, we have another triangle. Let's find out what kinds of things we have here. We have an angle given to us up here. We have a hypotenuse, but I can see that actually has nothing to do with what we're doing. So I'm going to scratch that right back out so we don't get confused. The side next to the angle is given to us, which will be the adjacent side. And then we also have a question mark opposite. So that will be our O. Okay, so A and O, looking at what we have available. Hypotenuse is not included. O and A, that looks familiar. So we're going to go with TOA. So there we go. Okay, so we are looking for the opposite. So that means we're blotting out the O, which means O equals T times A. So O equals T times A. Okay, so let's plug those in. T, so tan, and we have 30 degrees, times our adjacent, 5.45. And again, now we're just punching that into the calculator. So tan, find that button, 30 times 5.45 gives us 3.14, and let's round it up to 7. Good so far? Okay, let's move on to the third one. Okay, so we have an angle given to us down here. We have a hypotenuse that's included, awesome. And we have an adjacent side that has a question mark. This would be our opposite, but nothing is given to us here, so I'm just going to leave it blank for now. We have a hypotenuse, okay, so that leaves us so and ka to work with, and we have an adjacent, which means ka. Now let's figure out which equation we need to work with. So we are looking for A, so that means if I blot it out with my finger, it leaves us with C times H. Excellent. Now we can pop in some numbers. So that is cosine, right? So cos 75, that's our angle, times the hypotenuse, so times 115. And then we just punch that in the calculator. So cos 75 times 115 gives us 29.764. So that is the length of our adjacent side. Excellent. Hope that's feeling a little bit more comfortable. Let's do one more. A little bit more practice. You are most welcome to pause the video and try them out on your own. And then you can tune back in to see if we came up with the same thing. Okay, so same thing here. We first want to mark out what do we have given to us. We have an angle given to us. That's excellent. There's nothing on the hypotenuse, so we'll leave it blank for now. A side is given to us right next to the angle, which makes it the adjacent. And opposite of the angle is a question mark, which makes this an O for opposite. Looking at our options, So and Ka both have the hypotenuse. O and A leaves Toa. Awesome. Writing that down, way too easy to get confused and bamboozled, especially in exams. Always write everything out, every little detail. It just helps you backtrack. Or once you come back to school, it helps you review your notes and study up. And it'll be much faster than learning from scratch from somebody else's notes. So Toa, we are looking for the O. So if we're blotting out the O, what we have left is T times A. O equals T times A. And now we're popping in the numbers. So tan 40 times 6.84 meters. Always keep track whether you're working in meters, feet, inches, anything like that. Okay, so tan 40 times 6.84 gives us 5.73, and we can round down, so 9, and we're in meters, saying that the opposite side here is 5.739 meters long. Now, if we had to find out the hypotenuse, we could do Pythagorean, a squared plus b squared equals c squared. Easy peasy. Now, for our next triangle, we have a degree, an angle given to us. There's something on the hypotenuse side, and adjacent right next to the angle is a question mark. So we'll call that an A for adjacent. So A and H, that's not this one, it's not this one, must be this one. Okay. We are looking for the adjacent, so if I blot out, if I blot out the A equals, leaves us with C times H. Okay, let's pop in the numbers. We have cos of 45 degrees times our hypotenuse, and here we have 10 feet. So finding our cos button, 45 times 10. 7.071, and we are in feet. Always make sure you keep track of that. It's too easy to muck it up, and those are easy points that you might lose because of it. Excellent. Let's do one more. Okay. You can see the visual is different, right? These triangles were this way, this one is rotated. It doesn't matter which way they are. So it's good to practice them being turned around in all sorts of ways to make it easier in your brain, just so they can look any shape or form or in any direction. If you need to rotate your paper around because it's more comfortable in your brain to look at it this way or that way, you can totally do that. Okay, so I see a question mark right at the hypotenuse. We can already mark that as an H. We have the angle down here. The adjacent side would be this one, but there's nothing there. So looking across, that's the opposite. Cool. We have an O and an H. So looking at our options, O and an H right there, we're going to have so. Now this is 4 feet and 3 inches. That is pretty hard to do math with. So first we need to turn this into decimal feet. So I'll leave the 4 alone for now because that's full feet. but the 3 inches I can turn into decimal feet. So 3 divided by 12 gives me that, 0.25. Of course, I could have done that in my head, but sometimes, depending on what they are, might not be so easy. We have to add our 4 to get the full number of 4.25 feet. So now that's something we can do math with. Okay, we're using so. We are looking for the hypotenuse. So if I blot out the h equals, leaves us with opposite over s. Excellent. So let's pop in those numbers. Opposite is 4.25 feet over sine 53. And again, popping that into the calculator, you can see I left the number. So 4.25, I can just leave that in there, divided by sine 53, gives me 5.32, and I can round that up to, and we are in feet. Excellent. So this concludes a first look at trigonometry, or an intro. Really most important is finding out what is given to you, or what are you looking for? What are the sides? Which angle are you working with? And from there on, it dictates, okay, this is the opposite, this is the adjacent, the hypotenuse is always the longest. And then figuring out, draw yourself the triangles every single time so you can be visual about it and blot out what you're looking for. If you're looking for the one that's at the top for all of them, then you multiply across at the bottom. And if you're looking for one of the bottom ones on any of them, you divide the top by the bottom. Then you pop in the numbers instead of the letters. And then you're off to the races and you can solve for what you're looking for.